Welcome back to Jackson Square. Last time we looked at multiplying fractions using area models. This time we want to look at multiplying fractions using the algorithm. Well, there's more than one way or more than one type of fraction problem you can have. So let's jump into what are those ways. You could have a fraction times a fraction problem. You can have a fraction times a whole number, or you could have a fraction times a mixed number. So what do you do when you have this? When you have a fraction times a fraction, you just multiply the numerators, and then you multiply the denominators. And then you always remember to simplify. So I'm going to zoom in so you guys can see that better. So you would multiply the numerators and multiply the denominators, and simplify. We always want to simplify. So we have an example here, 1/2 times 2/5. If we were using our estimating of products, who could tell me, is my product going to be greater or smaller? Is it going to increase or decrease? I hope you said it's going to decrease, because remember, when you multiply a piece by a piece, you end up with a crumb. Yes, you got it. So we are just going to multiply straight across. I'm going to rewrite the problem just because I wrote it kind of small. You're going to multiply numerator times numerator and denominator times denominator. You're going to end up with 1 times 2 and 2 times 5, which equals 2/10. Remember, if it can be simplified, we want to simplify it. So I don't need to do my factor trees to find the GCF of this particular problem. I know off the top of my head that the GCF is 2. So I'm going to divide the numerator and denominator by the greatest common factor. I will end up with 1/5. Is 1/5 smaller than 1/2? Yes. Is 1/5 smaller than 2/5? Definitely. So our estimation was right on. So if I multiply a fraction times a fraction, you should be able to check your work that that fraction, the product, is smaller than the original fractions. Let's look at multiplying a fraction times a whole number. When multiplying a fraction times the whole number, make the whole number a fraction. So before I start anything, I need to make that whole number a fraction. Well, how do I do that? By placing it over 1. That means you want to have the denominator to be 1, okay? You're going to multiply across numerators as before and across denominators. Same process. And always simplify. So we're going to see and follow these steps. I have 2/3 times 5. Again, zooming in on that. 2/3 times 5. It told me to make this 5 a fraction, so I'm going to rewrite it as a fraction. How do I do that? By giving it a denominator of 1. Now it's a fraction. 5/1. So you should think in your mind that 5 has an invisible 1 underneath it. If you're in my classroom, check out the invisible math poster. You will find lots of invisible things that happen in math. The 5 has an invisible 1. Once I place it over a 1, I can multiply as normal. I'm going to multiply numerators and denominators together. That would be 2 times 5 over 3 times 1, which will give me 10/3. What in the world? What kind of fraction is that? Improper. So if it's an improper fraction, please take the luxury of making it a mixed number. How do we do that? We do it with our little mnemonic device, table. Top in, bottom out. You're going to divide. The numerator goes in the house, denominator stays out, top in, bottom out. How many groups of 3 are in 10? 3. 3 times 3 is 9. I subtract. I will have a remainder of 1. We want to remember the parts that we need to make our mixed number. We need our quotient, we need our remainder, and we need our divisor, which is also known as our original denominator. So what's going to be my mixed number? 3 and 1/3. 10/3 is the same as 3 and 1/3. So we're done. Let's look at what happens when you multiply a fraction times a mixed number. A little bit more going on this time, but still the same process basically. So first you want to convert the mixed number to a improper fraction. It's just easier to work with the improper fraction. Then you're going to multiply across numerators and denominators and simplify. A couple years ago, my kids used to always say, simplify, like Wi-Fi. You're going to simplify and then convert back to a mixed number. So this one has a lot of work going into it. A lot of different steps going in. We're going to make the mixed number improper. Then we're going to multiply across numerators, multiply across denominators. We're going to simplify, and then we're going to convert it back to a mixed number. So I'm going to work the bottom problem, and I'm going to have some side work stuff going on. So my first is, oh, I can't write with this. This is too light. Let me grab purple. 1 5/9. I hope you remember how to make this into an improper fraction. We do the Texas method where we're multiplying and adding to the product. We're going to multiply 9 times 1, which gives us 9. Bring the 9 down. We're going to add 5 to the product of 9. That gives us 14. 14 is my new numerator. Okay? My denominator stays the same. Okay? So 14/9. 1 5/9 is the same as 14/9. Times, oh my goodness, I have 2 of these things. Oh my God. All right, so I'm going to make 2 1/7 also improper. Same process as before. I'm going to multiply the denominator times the whole number and then add the numerator to their product. So 7 times 2 equals 14. Bring that down. 14 plus 1 equals 15. So my new numerator is 15, and my denominator of 7 stays the same. Okay? Same. So this becomes 15 sevenths. So now I have 14 times 15, 14/9 times 15 sevenths. So again, you're going to multiply straight across. 14 times 15 and 9 times 7. I've done this work already. If you need to multiply, again, you could do that side work here. Things to remember, if you have 2 numbers down here, you should have 2 lines that you need to add up. You would have a placeholder of a 0 here, okay? When you multiply those together, hopefully you will get 210, and 9 times 7 will give us 63. So now I need to simplify this fraction, or I could make it into a mixed number. Whichever one you think is easier. I think I'm going to make it into a mixed number first and then simplify. The order doesn't really matter on that one, even though the directions said simplify first. Because this number is so monstrous, we're going to divide first. So I don't know my 63 timetables. I'm going to do a little bit of side work. I know that 6 times 3 is 18. 6 times 4 is 24. That would be too big. So let me try 6 times 3. 3 times 3 is 9. 3 times 6 is 189. I know 4 would be too big. So I think this is the closest I would get. Then I'll have to subtract 189 from 210. And what would I have left? 21. So this would be 3 and 21/63. Oop. Y'all can't see me. All right, this will be 3. That's a whole number. 3 and 21/63. That is what it would become. 21/63. You can use a prime factorization tree to find the GCF of it. Let's do that. So you guys can just see that again. It's 21/63. 21 is 3 times 7. These are both prime. Circle it. 63 would be 7 times 9. Circle. 9 is 3 times 3. Circle, circle. So 21 is 3 times 7. 63 is 3 times 3 times 7. What do they have in common? I see that there is a 3 in both lines, and I see that there's a 7 in both lines. So each one of those will get a representative. So a representative of 3 and a representative of 7. I take those two and multiply together to get 21. So the greatest common factor of 21 and 63 is 21. Take a second. All right, flip my paper over. So I'm going to divide this by 21 and divide this by 21. I end up with 3 and 1/3 is my final answer. So did a lot of work go into this one? Yeah, a lot of work kind of did go into it. But this is a lot of great practice of things that we've built, right? And things that we wanted to see. So remember, we said anytime you multiply an improper fraction times an improper fraction, your product is going to increase. It's going to be greater than both of the quantities. Look, 3 and 1/3 is bigger than 1 and 5/9, and 3 and 1/3 is greater than 2 and 1/17. So see how that estimation is paying off? I know that my answer is right because the product is bigger than both of the original quantities. So I'm like, yeah. This problem, I really like it because it encompasses a lot. It was changing mixed to improper. It included multiplying fractions. It included changing a improper to a mix and simplifying fractions. So if you can get the right answer here, you have pulled off, you have pulled off showing your mastery of several different skills here. So you should challenge and be excited for problems like this where you can show your skill set by changing improper to mix and mix to improper and simplifying, doing factor trees if you have to. This was like 4 different skills right here in this one problem. So what I'm going to leave you guys with is some practice problems, one of each kind. A fraction times a fraction. What is 1/3 times 9/16? Make sure you guys do that one. What is 3 times 2/9? And what is 1 3/8 times 3? So I'm going to make sure those get on the board so you can copy them down and work them out. So this is your time to pause and practice. and I'll come back with the answers. Welcome back. So let's get to it. Here we're just multiplying straight across. 1 times 9 is 9. 3 times 16 is 48. Again, you could do some prime factorization trees. Some factor trees and some prime factorization to find what is the GCF. I found that it was 3. So the final answer will be 3/16. Hope you got it right. The next one, 3 times 2/9. 3 times 2/9. Make this a fraction by putting over 1. Zoom in for you guys. And then multiply straight across. 3 times 2 is 6. 1 times 9 is 9. Clearly, we can simplify this fraction, right? Again, the GCF would be 3. And we would end up with 2/3. Final answer. Got it? All right, the last one is a little bit of work. Let me draw me a little scribbly space so I don't get into the other problem. First thing I need to do is make this a improper. So I'm going to go 8 times 1 equals 8. Bring my 8 down. 8 plus 3 is 8, 9, 10, 11. 11 eighths is my new fraction. Remember, my denominator stays the same. So this will become 11 eighths times, and this 3 becomes what? Yep, 3 over 1, right? 3 over 1. So once I have that, multiply straight across, just like before, I will end up with 33 eighths. 33 eighths is an improper fraction. So we T-bow that thing. Top in, bottom out. So I'm going to put 33 inside the house, 8 outside of the house. How close can I get to 33? 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. So 4 times 8 is 32. I subtract. I get a remainder of 1. So now I can write this as a mixed number. Remember, we want the quantity. Quotient, yes. The quotient, the remainder, and the divisor. Quotient, remainder, divisor for a final answer of 4 1/8. 4 1/8 is our final answer. Again, this was a great challenge problem because you showed a lot of skills in here. So hope you got 4 1/8. Hope you were patting yourself on the back for remembering to change a mixed to improper, remembering to make that whole number a fraction, remembering to do T-bow, and converting it back to a mixed number. So if you were able to get all 3 of these right, you are ready to go out into the world and practice multiplying fractions. I'm so proud of you, and good luck.